Warm welcome to everyone joining us today. Imagine if you could own an EV that drives nearly 1,000 miles on a single charge. It retains almost all of its battery capacity after 3 years. It performs reliably in a wide range of temperatures. It recharges in just 10 minutes and costs about the same as an ICE car. How could you say no to that? Yeah, let's be real. It sounds like something out of a sci-fi movie, right? Because in today's world, even hitting a 500-mile range is still a tough challenge that many EV automakers, including Tesla, haven't fully cracked yet. However, we're willing to bet that's about to change. A revolutionary new battery is heading into mass production, one that could be a true game-changer for EV range. Elon Musk might soon bring it to Tesla because if he doesn't, the company could face a major setback. At least 3 other automakers have already poured serious investment into this technology. You might not believe it, we didn't at first either, but the truth is undeniable. Yes, we're talking about solid-state batteries, the most powerful battery technology the world has ever seen. So, what makes them such a breakthrough? And why do they pose a serious threat to Tesla's 4680 battery? Let's dive in. While we've touched on this battery in earlier episodes, many people still don't fully understand what solid-state batteries really are. So here's a simplified explanation. All batteries in the world share 4 basic components: an anode, a cathode, a polymer separator, and a liquid electrolyte. And it's the electrolyte that we need to focus on here. Solid-state batteries also have those same 4 components, but the key difference, the real game-changer that's earning them so much attention, is the switch from a liquid electrolyte to a solid-state electrolyte. Before we go any further, if you're finding this deep dive into the future of technology valuable, do us a massive favor and hit that subscribe button. Then make sure to ring the notification bell. Your support is the energy that powers this channel, so join our community and help us keep bringing you these game-changing insights. So, why are automakers racing towards solid-state batteries? Market research firms predict that EVs will eventually replace ICE cars and become the dominant force in the automotive industry. And to take the undisputed lead in that future, EVs need to match the driving range of today's gas-powered cars. That means boosting battery capacity significantly. Now, there are 2 main ways to increase the power of an EV battery pack. The first is to simply make the pack bigger, go from 60 kilowatt-hours to 75 kilowatt-hours or more. But what's the trade-off? Increasing battery size means higher costs, more individual battery cells, extra weight, and more space taken up inside the vehicle. Sure, it sounds straightforward, but it's far from ideal. So, what about developing a new type of battery? One that's more powerful, safer, and faster to charge. That seems like a better direction, but it's not exactly easy. Lithium-ion batteries have been gradually improved over the years, but they've hit a wall, especially in terms of safety, mainly because of their chemical makeup. You see, modern lithium-ion batteries use a liquid electrolyte, which makes them vulnerable to damage. They can swell due to temperature changes, or even leak, or catch fire if there's a hard impact. These safety risks have pushed automakers to seek better solutions. That's why manufacturers are now trying to replace liquid electrolytes with solid-state ones to overcome the long-standing limitations of traditional lithium batteries. And this difference is a big deal. It's what could finally unlock a new level of safety and performance in electric vehicles. Of course, we admit that solid-state batteries aren't some brand new invention. Their potential was discovered years ago. In fact, Toyota is often seen as the pioneer in the effort to bring solid-state batteries into the real world. What's worth noting is that Toyota is confidently aiming to reclaim the ground it lost to Tesla and BYD, seeing solid-state batteries as the key weapon to elevate their EVs to a whole new level. Now, whether or not Toyota will actually succeed is up for debate, But there are growing signs that Tesla could be facing real competition. Right now, even Tesla's most advanced 4680 battery only gives the Cybertruck long range a range of 354 miles, with a massive 123 kilowatt-hour battery pack. Sure, Elon Musk has said that 300 miles is enough for daily driving, and that may be true. But in our view, EVs will never truly break through unless they can consistently exceed 400 miles of range. Without that, it's tough to compete or convince drivers to make the leap from gas-powered cars to electric. That's why Toyota's claim that its upcoming EVs could travel up to 745 miles on a single charge is such a big deal. That's not just impressive, it's a game-changing number. It beats many gasoline vehicles in range, while offering the cost savings of electricity over fuel. The Japanese auto giant says their EVs will be insane once they're powered by solid-state batteries. So what exactly are the advantages of solid-state batteries? Over the past decade, EV batteries have become significantly more efficient. Back in 2015, a typical EV battery had an energy density of around 150 watt-hours per kilogram. Today, some of the best lithium-ion batteries have reached 300 watt-hours per kilogram or more. Solid-state batteries stand out because they're much lighter and offer far higher energy density than traditional lithium batteries. With energy densities exceeding 500 watt-hours per kilogram, they blow past the 250 watt-hours per kilogram average of conventional lithium-ion batteries, allowing much more energy to be stored in the same weight. That's a huge deal for electric vehicles, where both weight and efficiency are critical. Instead of the liquid electrolyte and separator used in traditional lithium-ion batteries, solid-state batteries use solid materials like solid oxides or sulfides as their conductive electrolyte. This solid material is denser than liquid or gel-based electrolytes, enabling solid-state batteries to generate more energy per unit of weight or volume. Another benefit of Toyota's high-energy density batteries is that they'll reduce how often you need to charge your car. Fewer charges means saving both time and money. Thanks to their higher energy density, solid-state batteries allow Toyota to boost both the power and performance of their EVs. That's because these batteries can deliver higher voltage and current, improving acceleration, handling, and top speed. Now imagine this type of battery paired with Tesla's 48-volt electrical architecture. It's an exciting possibility. It's clear that 745 miles already beats the reigning range king, the Lucid Air. But Toyota isn't stopping there. Their second-generation solid-state battery tech is pushing the boundaries even further, promising a driving range of up to 932 miles. That's nearly 1,000 miles on a single charge, more than 3 times the range of most popular EVs today. Honestly, this kind of claim would usually raise eyebrows, especially coming from Toyota, a company known for making bold promises that don't always materialize. But we can't ignore the potential this time, and here's why. Toyota currently holds over 8,274 patents related to solid-state battery technology. That level of commitment and innovation suggests they're truly serious about making this happen, not just hyping it up like before. And it's not just Toyota making progress. Other companies have hit solid-state milestones too. Samsung recently unveiled a solid-state battery with a range exceeding 600 miles and the ability to charge up to 80% in under 10 minutes, boasting an energy density of 500 watt-hours per kilogram. Factorial and Mercedes claim their solid-state batteries can offer over 600 miles of total range, while also cutting battery weight by 40% and reducing size by 33%. QuantumScape, another frontrunner in the space, has developed lithium-metal solid-state batteries that also show strong potential to reach 500 watt-hours per kilogram energy density. Thanks to the use of advanced materials, solid-state batteries deliver a dramatic boost in energy density, something even Toyota openly acknowledges. While traditional lithium-ion batteries typically use metal lithium in the anode and graphite or silicon in the cathode, solid-state batteries open the door to higher capacity materials. The anode can now be made from high-voltage compounds, while the cathode might feature lithium-rich manganese or silicon-carbon blends. Yeah, it's easy to see why solid-state batteries offer a level of energy density that conventional lithium batteries simply haven't reached in years. But let's be real. High energy density alone isn't enough. If it takes hours to fully charge, no one's going to be impressed. So, how fast can solid-state batteries charge? Clearly, we've all seen that EV charging times have been shrinking over the past few years. It used to take hours to fully charge an EV, just to get around 200 miles of range. But now, thanks to advancements in battery tech and charging stations, we're talking about minutes. On average, it takes about 35 minutes to fully charge an EV at a Tesla supercharger. However, compared to the few minutes it takes to refuel an ICE car, 35 minutes still feels pretty long. That's why many customers remain hesitant about EVs. They're worried about running out of battery mid-trip and struggling to find a charging station. Most people simply don't like waiting 30 minutes at a charging stop. With Tesla's superchargers, you can charge a 2170 battery pack up to 80% in about 35 to 40 minutes. The newer 4680 battery cuts that down to roughly 30 minutes for a 10% to 80% charge. But solid-state batteries aim to be even faster. QuantumScape's solid-state battery tech, for example, can reportedly charge up to 80% in just 15 minutes, thanks to its ultra-fast ceramic separators. Sounds quick. Toyota has made an even bolder claim, saying their solid-state batteries will be able to charge from 0 to 100% in just 10 minutes, with potential charging speeds of 10C or more. That means you could take a 10-minute power nap in your car and be ready to drive nearly 1,000 miles. Sounds unbelievable, right? But ultra-fast EV charging in just 10 minutes is already being tested. CATL, a key Tesla partner, has released two super-fast charging battery types, Shensing and Shensing Plus. Both tested to fully charge in just 10 minutes. Solid-state batteries use metal oxides, metal sulfides, or solid polymers as electrolytes, and the softness of sulfur is a key factor that help ions move more easily. In the case of oxide-based electrolytes, they can handle higher voltages, meaning more ions can be pushed through the electrolyte. Some studies suggest that solid-state batteries can be charged and discharged over 5 times more cycles than traditional lithium-ion batteries, significantly extending their lifespan. In contrast, the solid electrolytes in Toyota's solid-state batteries actually perform better under heat. Since fast charging generates a lot of heat, this feature ensures strong performance during rapid charging sessions.
So, are solid-state batteries safer than regular lithium batteries?
Thermal runaway and EV fires have become major concerns for customers, battery designers, and automakers. While such incidents are rare, they can be very serious because, as you may know, lithium fires burn for a long time and release extremely toxic smoke. That's why safety is a key question for any battery technology. Lithium-ion battery fires are uncommon, and most automakers already include protective casings and safety measures to prevent them. But when these fires do occur, they can be intense and very hard to extinguish, sometimes requiring thousands of gallons of water. That's one reason why many EV skeptics liken driving an electric car to sitting on a ticking time bomb. At first glance, simply switching from a liquid to a solid electrolyte already shows that solid-state batteries offer clear safety advantages. They eliminate the flammable liquid electrolyte and replace it with a non-flammable solid one. Solid electrolytes also typically operate across a wider temperature range, helping reduce the risk of thermal runaway caused by overheating cells. Even heat generated from external sources is often less of a concern with solid-state designs. Tests like puncturing, slicing, or fast-charging solid-state batteries have been conducted, and in most cases the results show they don't catch fire or explode. Solid-state batteries are significantly safer than lithium-ion batteries, especially in situations involving overcharging, mechanical damage, or external short circuits. This makes them very attractive for use in EVs and other applications where safety is critical. That said, they're not completely foolproof. Solid-state batteries still need further improvements to fully eliminate the risk of thermal runaway under extreme conditions, like temperatures above 300 degrees Celsius or internal short circuits caused by manufacturing defects. But even so, they pose far less risk than current battery technologies. And creating electric vehicles that don't catch fire is a massive win for drivers, nearby residents, and firefighters alike. Many EVs today are only expected to last a few years, while people typically expect their cars to run for a decade or longer, sometimes even several decades. Now, we can't make promises yet, since there's been no long-term testing of EVs using solid-state batteries, but based on all the advantages we've listed so far, we believe it's reasonable to expect better durability than current lithium-ion packs. So yes, solid-state batteries offer high energy density, fast charging, and better safety. It sounds like the ultimate battery, right? But with so many advantages, a big question naturally comes to mind. Why aren't these batteries already mainstream? What's stopping them from hitting the mass market? And more specifically, if Toyota says it'll have solid-state batteries by 2027, why the delay? Yeah, nothing is perfect, especially in the world of technology. Every method or product has its pros and cons, and Toyota's solid-state battery is no exception. When we ask why such a promising battery is taking so long to reach the market, the answer becomes fairly obvious. Solid-state batteries aren't a brand new concept. They've been under research for years. That tells us that developing this type of battery doesn't just require significant R&D effort, but also face serious challenges in mass production. According to Toyota, they claim their solid-state battery will cost 50% less to produce. But don't get it twisted. This doesn't mean it'll be 50% cheaper than current lithium-ion batteries. It just means it'll be 50% cheaper compared to Toyota's own original cost estimates for producing solid-state batteries. Still, the phrase, "cut costs in half," has captured most of the public's attention. Traditionally, solid-state batteries have been extremely expensive to manufacture. That's largely due to the high cost of raw materials and the strict purity levels required during fabrication. For example, lithium sulfide, a potential material for solid-state batteries, can cost 5 to 10 times more than lithium carbonate. So yeah, the two main barriers holding solid-state batteries back are materials and manufacturing. Compared to conventional lithium-ion batteries, the components used in solid-state tech, like ceramic or glass electrolytes, are much harder to produce uniformly at an industrial scale. They require highly controlled environments with near-zero humidity, specialized machinery, and advanced processing techniques that most factories today simply aren't equipped for. While the battery remains the most expensive component of an EV, every investment decision in new technology must be weighed carefully, especially when it comes to cost. And right now, the production cost of solid-state batteries is still significantly higher than that of lithium-ion batteries, not just because of materials, but also due to labor-intensive assembly processes that can't yet be fully automated. Another lesser-known obstacle is the issue of dendrites, tiny metal crystals that can grow through the electrolyte, potentially causing short circuits and reducing battery lifespan. Even though solid-state batteries are expected to be safer overall, the dendrite problem still exists. According to available research, scientists at Harvard University have developed a solid-state battery design using silicon that blocks dendrite formation, and their tests have shown up to 10,000 charge cycles, which is double the lifespan of today's lithium-ion batteries. Toyota is also pursuing similar approaches, so in the end, the biggest hurdles aren't in the idea. They're in the materials and the manufacturing process, both of which are still holding solid-state batteries back from mass adoption. However, Once those barriers begin to fall, solid-state batteries won't just be an upgrade. They could reshape the entire EV industry. Especially if bold claims from Toyota, like commercializing solid-state batteries by 2027, come true. It could be a game-changer. The edge in range, charging speed, and durability would dramatically favor early adopters in the battery tech race, and that would put real pressure on Tesla and other competitors to speed up their innovation, or risk losing their lead in the next generation battery era that's approaching fast.